This week on Quality Digest Live, we talk to Luke Yoder of Faro Technologies about an interesting alternative to check fixtures.
Plus, preparing American students to succeed in American manufacturing. That and more when we come back.
This week's sponsor of Quality Digest Live is Intertech. Learn about device classification, technical documentation, and quality systems requirements for medical device manufacturers in 4 of the world's largest markets. Visit intertech.com.
Welcome back to Quality Digest Live for April 27th, 2012. QDL is your weekly look at who and what is making the news in the world of quality. I'm Mike Richmond, publisher of Quality Digest.
And I'm Quality Digest Editor-in-Chief, Dirk Ducharme. Well, let's start this week with a few news items. First, how DuPont is reusing waste rather than sending it to a landfill. In the story Getting Back to Zero at DuPont by Mark Gunther, the author describes some of the ways that DuPont's buildings division has gone from sending 81 million pounds of waste to landfill in 2008 to zero. In 2012,
Very
81
impressive.
million pounds to zero. The building division's major products are Corian, solid surfaces, Zodiac quartz surfaces, Tyvek weatherization systems products, and landscaping products. Waste includes unusable raw materials, product scrap, construction debris, and actually half-eaten cafeteria food.
Yummy.
So it took 3 years for DuPont to figure it all out, but in the end they actually found a use for all this stuff. Pieces of Corian are crushed up and made into gravel as a landscaping material. Bits of Tyvek, I don't know why they didn't think of this earlier. Tyvek, they shred it and make it back into Tyvek.
Yeah.
Took them 3 years to figure that one out. I don't know.
Great.
Okay, cafeteria waste is turned into worm bedding. Sold to that strikes me as funny. Sold to bait stores, fishermen, and gardeners. Waste that can't be made into anything else is simply burned as energy. So here's the thing. DuPont expected that this product would cost them money.
Sure.
A lot of people think that when they go into some sort of waste reduction problem, but they actually made money from the waste and avoided the cost of landfill disposal. Now, the funny thing that struck me about this is Bill Levinson, our resident Henry Ford historian and columnist, would have gone like, well, duh,
course.
Ford was doing this 100 years ago, right? I mean, the idea that waste, actually finding a way to reuse your waste is not a cost burner.
Right.
It actually has in DuPont's case, a small revenue stream, but still, it was a revenue stream and actually helped them create a more environmentally friendly company.
That's great. We love running stories like that. We're going to talk about Bill Levinson a little later in the show.
Yes, we will.
So we'll get back to that. Okay. Another interesting item that we covered this week comes from Andrew Sobel, who has a new book out from Wiley titled Power Questions, Build Relationships, Win New Business, and Influence Others. Okay, Sobel writes about a common situation that any of us in business understand all too well. Awkward, emotionally charged, or otherwise inefficient conversations. Now, whether it's with a client, a coworker, an auditor, or anyone else, everyone has had that terrible feeling of an important conversation, slipping out of control. So how does one regain control? As Sobel writes, it's all about using one magical 7-word question. Do you mind if we start over? Many times I've said that on this show.
Yes.
Do you mind if we start? But we don't.
I think I've said it to you a couple times.
Yes, I think so.
Just do this over again? Okay.
Now, if you use this phrase with sincerity and make a real effort to break the negative flow of the discussion and start anew, you'll be amazed at how well this works. Now, most people, of course, want to have peaceful and productive conversations, right? So when you recognize that you have one going in the wrong direction and take steps to course correct, you'll almost always find a willing partner on the other side of the desk or the phone or the webcam.
Nobody likes that uncomfortable conversation.
No, and it's a partnership. A conversation is a partnership. It's an exchange, and both parties know when it's not going right. So you want to get it back to the wholeness of that if you can. So effective communication is a hallmark of today's interpersonal quality endeavors, and as such, anything we can do to encourage better conversations will naturally lead to higher quality products and services. And hey, that's all good for all of us, right? So we encourage you all, give that piece a read. There's a link just below the player page right here. And as always, let us know what you think.
Great. Well, leading into kind of our tech
Our
week,
tech show.
Our
Yes,
tech show.
That's right.
We have an interesting interview right now for those of you who spend a lot of money and resources on check fixtures. In many cases, there is actually an alternative to fabricating and storing dozens, or for some company, hundreds of these check fixtures. Because many of them are good for only inspecting one part.
That's right.
And so you've got dozens of these things. So today's new 3D measuring hardware and software can often replace check fixtures. And here to discuss that topic with us today is Luke Yoder of Faro Technologies. Hi, Luke, you with us?
I am. Thank you very much, Dirk and Mike, for having me today.
Thank you.
Thanks, Luke.
Well, Luke, actually, just to start off, for those of our viewers who might not know what a check fixture is, why don't you just briefly describe a check fixture?
A check fixture would be a custom fabricated gauge that is designed for an individual specific part that's being manufactured. That gives me a no-go indication as to whether the part's good or not. So the part goes on top or inside the check fixture. If it fits in the fixture, it's considered a good part. If it doesn't fit, it's not considered a good part.
Okay, so basically, and these tend to be, or not tend, they usually are custom fabricated fixtures that hold a particular part, or maybe a couple of parts, similar parts within maybe a series of products that a company might make. Is that right?
That is correct.
Yeah. So if they make dozens of parts, they may have dozens of fixtures or hundreds of fixtures.
Well, since they're dedicated for a specific part, each part would have its own dedicated check fixture, and these can be very expensive. They can be $5,000 to hundreds of thousands of dollars.
Yeah, so tell me a little bit. I mean, you guys just did Faro just did a webinar with us. Actually, you were the subject matter expert on that, and you were making the case that check fixtures actually can be a real money pit. That there can be a lot of money, a lot of cost going into check fixtures. Kind of tell us a little bit about where those costs go.
Well, the initial cost is the purchase cost of the check fixture that we just talked about. The maybe $10,000 to $100,000 purchase price of that. Other costs that could be associated with it are retooling costs for the fixture if the part changes throughout its production life cycle. An example would be an automobile. There are many check fixtures that are used to validate parts that are made for a car, sheet metal stampings, interior plastic injection molded parts, for example. So if that part changes, maybe there's a warranty issue associated with the part, or a design change, or maybe they're having an assembly issue, the end user may ask the supplier to make an adjustment. Maybe I need to add one more inspection point, or maybe I need to inspect another detail on the part, and so I have to retool that fixture to be able to get that inspection data or information. So that can be a cost. Annual recertification costs associated with check fixtures. If I'm manufacturing 100 parts and I have 100 different dedicated check fixtures, there's a cost to going out to a third party to have each one of those validated on an annual basis to make sure that the geometries and the details of the check fixture are still correct. And then just the sunk cost at the end of the project or the life cycle of the part production run. And, I get to the end and I have this dedicated check fixture that has no value to me anymore because I'm not making that part.
Yeah, Luke, we just threw a slide up here that I think kind of describes some of that. If our viewers can see it here, on the left-hand side, we've got a check fixture. This was some information you sent us earlier. You're saying here a fixture might run anywhere from $40,000 to $140,000 per part. Storage, I guess, is where it can be very pricey. $1,600 to $5,600 per part per year. So the storage cost can actually be a major portion of dealing with check fixtures, particularly if you have a lot of them.
Yes, exactly. So it has to do with warehouse space, additional facility that needs to be purchased or built to be able to warehouse all the various types of check fixtures that are needed.
Okay.
And in aerospace, for example, there are aircraft that have been maybe out of production for a long period of time, but there's still a repair parts business that's associated with existing aircraft that are being used in service. And so those manufacturers may not want to throw that check fixture away, because if that part is ever required for a replacement order, MRO, maintenance or repair type activity, they want to be able to go grab that check fixture. Well, that fixture may sit there for a year or 2 years and not get used until a and the order comes in to make one more piece.
Okay, so what's an alternative to this then? We've kind of established the cause that check fixtures are pricey, necessary but pricey. So what is an alternative to this?
Well, one of the alternative solutions is what we presented on Tuesday, and that's the Ferro Edge Arm, which is a portable three-dimensional measurement device that allows me to utilize software to guide an operator through a measurement process. And I use the Ferro Arm to measure geometry, plane, circle, surface profiles, these types of things. The software guides me through that measurement process, and at the end of that process, as an operator, that may be out on the shop floor, I get an inspection report that tells me whether the part is good or bad. So I get that attribute of good or bad, go, no go, but the added benefit is that I get what's called variable data. So I have actual measurement data that tells me how far off hole locations are, how far off their diameters may be, if I have surface profiles, in the circumstance that I'm measuring directly to a 3D CAD file in the software. I get finite numbers that tell me exactly how to make adjustments to my manufacturing process to make good parts.
And why does this replace, I guess I missed the connection there, why does this replace a check fixture? Don't you still need some sort of fixture or custom something in order to measure this part, or is it completely fixtureless?
This can be totally fixtureless. So parts that have the ability to hold their own shape don't need any type of fixture to hold them, and so I can simply put the part down on the table and clamp it and be able to go through and start to measure all the geometry on the part.
Because you don't need any kind of orientation. I mean, that's part of what the software does, right?
The software does all of that. So if there are datums on the part and there's geometric dimension and tolerancing, like true position on holes that are off of these datums, the software takes care of all of those calculations. I don't have to go through a process of putting the part in a specific orientation. I can simply place it on a table, clamp it down, and take the Ferro Arm, measure the geometry as I'm being guided through the inspection process via software, and the software will do all those calculations and tell me my acceptance or rejection criteria result.
So it sounds like the root of using, and you're obviously you're with Ferro, so you're referring to a Ferro Arm, but really pretty much with the right software and the right 3D measurement hardware, whether it's an arm or a scanner, perhaps a tracker, you could get rid of fixtures because you don't have to do all of this orientation and alignment that you normally would with a fixture. Do I have that right?
It is correct, but even beyond that, it gives me the flexibility now to measure many different parts with one system. I don't have to have a dedicated tool or a dedicated fixture for each part. I can use this one flexible, technologically advanced measurement system to be able to do part inspection on many types of parts. And then another added benefit is if that part changes or if there's additional features on that part that we need to measure, we simply go into the inspection software and make an adjustment to that inspection procedure. And so really there's no retooling cost. There's not the disadvantage of that check fixture being sent out to be retooled, during which time I'm not able to produce parts because I don't have a gauge to be able to check them to make sure they're correct. I can simply go in and make some software adjustments to my program. I'm ready to continue measuring.
Okay. Luke, we're running out of time here, but I'm going to go back to my slide here. On the left-hand slide we'd seen the cost of check fixtures. On the right-hand side, we've got compared to a portable CMM solution. I just kind of want to run through these and just real briefly talk about it. I'm not sure if you have the slide in front of you, but it looks like, the portable CMM portion of it, so the hardware portion of it could run you anywhere from 20 grand to 100 grand, depending what kind of technology you're using. But the rest of these costs would be fairly standard no matter what hardware you're using, right? Your modular tooling, anywhere from $3,000 to $10,000. And I'm assuming that's not per part, that's just some sort of modular tooling system that you can adapt to any part?
Right. The comparison that we put together here could be a comparison between buying one dedicated check fixture for a specific part and buying the portable measurement solution for that individual part. And so if you look at it to some degree, the costs are almost a wash, right? You look at $40,000 to $185,000 versus $26,000 to $113,000. You could say, well, those are pretty comparable in cost. The benefit, though, of the portable device is that it doesn't only just measure that one part, it allows me to measure many other parts. And so I could look at a project for which I'm manufacturing 10 components for a car, let's say, and as opposed to having that that check fixture cost of $42,000 to $100,000 per piece, I'm going to buy one portable measurement solution to be able to measure all of those. So you start to get into a magnification of savings from part to part to part. And that really is one of the key benefits of it. It's not just comparing the price for one part. It's the fact that I can measure as many parts as come through the door with this flexible technology.
Okay. Well, Luke, we're out of time here. Thanks for describing that to us. Comparison between check fixtures and a portable and alternative means of well, actually you get rid of a check fixture. Yes, you just have regular modular fixturing and portable CMM and some software. So that was Luke Yoder from Faro Technologies. Luke, thanks for joining us.
Thanks, Luke.
Hey, thanks so much for having us, and hopefully our viewers and listeners will visit Faro.com to learn more.
There we will.
Thank you.
And by the way, we will mention below the player, not the live player, but later on, we will actually have a link to that webinar, and you can learn a little bit more in depth about alternative to check fixtures.
About this very topic. Yeah,
about this topic.
It was a great webinar that you and Luke co-hosted. That Luke presented. You hosted on behalf of Quality Digest and Faro on Tuesday, on the 24th. Yep. So all of you out there who are watching this again on demand, the link will be just below the player. You can go out to WebEx. You can register for the event. Watch it on demand at your leisure and get a much deeper dive into this very topic. It's really interesting because it is potentially a huge savings. Yep. Depending on what your application may be. It's a huge savings for people that are in this space and certainly something worth considering. So check that out. Okay. Now we're going to continue.
Bill Levinson.
That's right. We're going to continue with our technical aspect of today's show because we'll get into this a little bit later because we were also out in New England looking at
Rhode Island. Yep.
In Rhode Island not too long ago. We were looking at one of these as well. But the article that ran in Monday's issue of Quality Digest Daily was entitled P-Tech, an old but good idea, and that's by, of course, Bill Levinson, William Levinson. And now, if you know Bill Levinson, and you've read Bill Levinson, as we have, you know there's two things that are always going to be mentioned in a Bill Levinson article. One is Henry Ford.
Right.
Two is U.S. manufacturing, the importance of U.S. manufacturing and the primacy of that.
There you go.
And of course, in this piece, he weaves those two things together very beautifully. He talks about P-Tech, and P-Tech is in Brooklyn, New York. It's Brooklyn's Pathways in Technology Early College High School. It's a tech school, trade school, and it focuses on STEM education. And the hopes of this school is that it will give its graduates a leg up in filling the increasing number of job openings in American U.S. manufacturing. We've heard this from many of our users and our contributors that this is a big problem. It's not so much that the jobs aren't there. The jobs are there, and the jobs we think are going to be there in increasing numbers in U.S. manufacturing going forward. The bigger issue, the underlying issue is, do we as a society, is our educational system helping to produce those people that can fill those jobs going forward? Are we doing enough with STEM education? We talk about that a lot. Of course, Bill is going to harken back to Henry Ford. Henry Ford's trade school back in the early part of the 20th century was a renowned tech school that gave its students this ability to go out and understand what cutting edge industry at that time really needed and what training they needed to go out and get jobs. In fact, a Henry Ford Trade School graduate, according to Levinson in his research, was employable even during the depths of the Great Depression.
They were sought after.
They were sought after people, and they were actually, as they were written, Henry Ford Trade School applicants wanted. So this was certainly a very prestigious educational opportunity for kids, mostly men, mostly boys at that time, to get out of high school, or maybe even at the end of their high school, replace them at the end of their high school, and get this degree and get this diploma, and be able to go out and work. So this is really what we're trying to do here. We're trying to look at the gap in American manufacturing and look at what the schools are doing or are not doing to help fill that. Now, certainly we look at universities, we look at schools. There's no shortage of doctors coming out of schools, or lawyers, or financial analysts, or any of these things. There's no shortage of English majors coming out, or history majors, sociology.
Liberal arts.
Liberal arts. But there aren't a heck of a lot of engineers. Certainly not enough to fill the
well, and I think not only, maybe more important is, because some people might argue, well, whether there are or aren't engineers. I think but I think you really could make a point that just technicians,
shop floor
not necessarily engineers, but the next step down.
I was just going to mention that it was the engineers at the top level, but even the level below that, the people that are actually doing the work on the shop floor, the technicians, as you say, are definitely not being filled.
Yeah.
Those jobs are definitely not,
particularly
being filled.
within certain industries.
Particularly within certain of these industries, and we see that. We talk to many of our people in our audience, so both contributors as well as our marketing partners, to say, hey, those people just aren't out there. Where are they coming from? Where's the next generation that going to come from? And again, we're talking about P-Tech. An old but good idea by Bill Levinson appeared in Monday's issue of Quality Digest Daily, and of course there's a link below so you can check that out. So we actually have been looking at this issue, as I said, and we were, as I mentioned at the top of the show, we were out in New England a few weeks back, and one of the things we did there was we met with Chris Vasconcelos.
Right.
And Chris is
New England Tech.
New England Tech, and they're in I believe they're in Warwick, Rhode Island. No, they're in East Greenwich, Rhode Island.
East Greenwich, Rhode Island.
Yeah. And New England Tech has a program where they work very closely with industry to produce these people, these technicians that are needed by industry. And we walked through the plan, and you talked to Chris, and
sure,
we'll have a Profiles in Quality episode with Chris at some point in coming weeks. But we walked their campus. I did with both that of Hexagon Metrology, and it was amazing to see what they're doing, what they're doing for their students, and how they're preparing their students to actually walk into these jobs and work from day one. I think what we need to do, and what you need to do, if you're out there in the space right now, is you need to think about what you're doing to support education, what you're doing to build that bond between what your organization needs and what the schools can provide. For instance, do you have an internship program in your organization? You should. If you don't, certainly there are a number of schools across the country, and I'm sure there's one not far from your area, that can provide students that can walk in and do this work.
Well, and equipment as well. And I know,
donate equipment, absolutely.
Hexagon does this. Yes. I know Faro does this. Yes. A lot of the large equipment manufacturers donate equipment to the, because the students have got to have cutting edge, today's equipment.
That's right.
To learn on. It doesn't help them to have 20-year-old technology when they're going to be going into a plant that's got cutting-edge technology. So a lot of the companies, metrology companies, are donating equipment to universities. And also get somebody who knows how to use their equipment. Whose equipment are they going to order if somebody asks them, hey, we need a new arm or whatever? What are they going to say? They're going to say the one they used.
That's right. That's right. Yeah. People come into these organizations and they move up the scale as time goes along. They move up the food chain. They're the ones that are ordering equipment. If they have a good experience from day one.
Worked for Apple.
That's right.
That's why you saw a Mac in every school.
A Mac in every school, and so this is important. Make sure that you're supporting them by making sure they have the equipment they need. Invite people into your facility if you can. If you can invite people in to tour your facility, some of these students, some of these groups, some of these professors and educators, and let them see what you're doing, and make sure that they understand what you need. Because if they don't know, you can't blame them for not giving you what you need. If you know what you need in terms of students coming out, graduates coming out and fulfilling these jobs, if you know what you need and you're not telling them, you're not helping them give that to you, well, then that's your fault.
Yeah.
That's your fault for not providing the guidance to those universities and those tech schools and taking that forward.
Yeah.
Again, this is something we've talked about a lot. We're very, very passionate supporters of this. We feel like it is the future of U.S. manufacturing to not only create the jobs, I think we're doing a fairly good job of that, but also create the applicants that can do the jobs and take U.S. manufacturing forward.
Yep.
Very important stuff. So really
more
in the theme of this whole tech show we're doing here today. And as a matter of fact, we have another
Tech Corner.
That's right.
Okay, today, well, thank you for that piece, Mike, and Bill Levinson for writing that.
That's right.
What we're going to talk about today, this is something that everybody deals with. I think we're on our camera here. Mm-hmm. You all recognize what these are. These are wires with terminals on the end of them. Mm-hmm. And you probably use these a lot, probably any kind of equipment that you manufacture. And actually, let me go to a different camera here. I want to, if we can go to the gauge cam here. Well, what I've got in front of me here is a few different wire terminal types. You all recognize it. I got a spade terminal up on top. And I've got a wire with a crimp connection on the end, and then I actually have that same type of connection, but in the housing it would normally go into. So these are kind of typical type of wire terminal connections that you would see. Now, one of the issues with this come back to our main cam here. One of the issues with terminals is that very often they are not properly constructed. This happens a lot, particularly in smaller, not contract houses tend to use the right equipment. Very often when you make your own terminals in-house, and I've seen this happen a lot of times in places I work, you don't use the right crimp. You don't use the right crimper for the right terminal, or if it's an automated machine, you may not have the machine set up right, and you're either under crimping, or you're not crimping, or you're over crimping. As under crimping, you can get a resistive terminal connection, which you don't want. Can cause overheating if the connection is intended for a high current application. You can overheat your connector if you don't have a very solid connection, or arcing, which is even worse. If you overcrimp, you can actually shear the wire and not even know it. You've probably all seen this. We have a terminal connection. It looks like it's connected. It seems firm, but if you look at it, the wire has actually been cut off inside the connector because it was overcrimped. So very often this is just setup type of stuff. You're not using the right tool for the right job. So it really is important, especially if you use a lot of terminal connections and you get them from subcontractors or from your own in-house assembly department, that you periodically test the quality of your terminal connections. And that's what we're going to look at today. That was a big lead in just to kind of set the stage. Okay, so what we've got here is a wire terminal tester from Mark 10. This is the model WT3200. You'll notice on the left-hand side is the control panel and display. This is a turret that allows you to select the terminal and wire size that you're going to grab hold of and that you're going to test. And then we've got actually our lever that actually pulls the wire from the turret during testing, and we'll show you that in just one second. So let me just go ahead and zoom in on this so we can see kind of the business end of all this. And there we go, got our display and control panel and turret. Okay, let's talk a little bit about the turret. Whole purpose for the turret here, you'll notice there's different size slots. These are for allowing you to select the wire size, the slot size that best matches the wire gauge and the type of terminal that you have. So the best one for me for my little ring lug here and the wire gauge that I'm using is this slot right here. So all you really do is you just pop that in there. We move this over into the holder. I push down the lever and that will pull the wire from there and we'll measure the force. But before we do that, a little bit about the display. So what we see here is your basic Mark 10 force display that you'll see in all of their instruments. If you've used any of their instruments, it functions the same way you're used to. What we're going to set up for is a peak reading, and this has several modes. You see this is a real-time reading right now. There is a peak mode which stores the peak reading from any measurement. So if I stop, it measures my peak right there. So what I'm going to do is I'm going to set an upper and lower limit for my test, and we'll operate in peak mode, and we'll be able to use the go, no-go gauge that you see on the left-hand side. A go, no-go will either show a down arrow if you're below your limits, a square if you're within your limits, and an up arrow if you're above your limits. Now, we're only interested in the lower because we don't care how high it goes. We really just care what the breaking point is. So I'm going to set my set points. You notice here I have my upper enabled, but I have it set for the max of this unit, which is 200 pounds of force. I have my lower enabled. I've set it to 25 pounds of force. That is, I want to be above that in order to say that this is a good terminal connection. And that's about it. I've got my limit set up. I'm in peak mode. I zero it out. I'm ready to take a measurement. So I've put my wire into my slot there. I now pull the lever, and we can see I measured 36.3 pounds of force. I've got a square there, which tells me that I'm actually within my limits, which means I'm above 25, lower than 200. Remember, all I care is that I'm above 25. So this wire passed. I'm going to press data, so that I store the data within the unit. The unit can store up to 1,000 measurements, and I'm going to zero it in order to get ready for my next test. And I'm going to do the same test again. I'll put in another wire, put it in the slot, and you can see how easy this is, and I'll take another reading. This one failed. Notice this one was 23.2 pounds of force, therefore didn't make the 25-pound limit, and my go, no-go indicator shows a down arrow rather than a square, which means it failed. So I'll go ahead and store this data, 0, and let's take one more reading just to see what we have. And I'll put another wire in the slot, another terminal, and we will test this one. This one is right at 25, strangely enough. It's not higher than 25, so it's right at the limit. That's considered a failure also. So we had one wire that passed, 2 that failed. I'm the one who built these wires, so you can see I'm actually not very good at constructing wire terminals, so don't send your wires to me. So we'll store the data. We'll say 0. Now you could keep going on like this, sorting wires. You could take your lot of wires, your sample of wires, go through, sort them and test them, and this would work perfectly well as a standalone gauge, go, no-go gauge to do that. But we're going to take a look at something else that we can do. So if we come over to our software view here, our screen share, you can see what we're looking at is the Mark 10 measure gauge software. This has a lot of functionality. We've actually covered this in an earlier show with a different type of Mark 10 gauge. What I really want to show you here is just the ability to download the data from the WT3-200 wire terminal tester into our software here. So I'm just simply going to click download memory. Okay, now all the data that I've collected on this over the past couple hours or so is shown here. All of my readings, there's been 22 readings, we can see down there at the bottom. You see my limit is set to 25, so you can see all the data that I took that was above 25, and you can see the last few readings I took that were, a couple were below 25 and one was above. I can now export this data to Excel in the lower left corner here, bring that data into another statistical package to do any kind of analysis I want to it. There is some basic statistics available on Measure Gauge. You can see in the upper right here, we got our minimum or maximum readings, average, curve, standard deviation, variance, so forth that we can do on any collected data. There's a lot you can do right here within Measure Gauge. If you need to do more, it's simply easy to export your data to Excel. So there you have it. This really is a very simple tool for doing wire terminal testing. Very easy to use, very easy to set up, only took a couple minutes. The software is pretty intuitive. So this is a great way to take a look at testing your wire terminals.
Solution for wire terminal testing.
And it's fast.
Yeah, it's fast. Yeah.
It's fast. I mean, when this is set up properly, when it's set up properly, it really only takes a couple seconds per terminal. You have your turret selected, you drop in your wire, you pull the lever, you look over at the left, it's either go or no go, and you pull your sample. You pull your sample lot of terminals. Obviously, it's destructive test, but you pull your sample of terminals, you test them, and you have an idea for how you're doing. So again, that was the Mark 10. Model WT3-200 wire terminal tester, just one of a series of force products from Mark 10.
From Mark 10, that's right. Great, thanks, Dirk, and thank you, Mark 10, for sending that on to us. Very interesting product that we love showing off on.
Yeah, these things are fun.
Yeah, they're fun. So
when I do them right.
Operator error. But other than that, no, great stuff. So thank you, Mark 10, for doing that. Okay, well, that's our show for this week. But before we close, I'd like to offer one more thank you, and that's to our sponsor, Intertek. Regulatory authorities in most major markets require or strongly prefer that manufacturers marketing medical products in their countries have a third-party audited and certified quality management system in place. Intertek can help you take your device to the next level. To learn more, visit www.intertek.com/5-step-market-approval-medical-devices. Or, more easily, simply click on the banner just below or just to the right of the player page right here. So check that out.
That's right. And next week we have a great article from Jim Benson.
Jim Henson?
Talking about Kermit the Frog.
It's not Jim Henson. It's actually Jim
Benson.
That's right.
But Jim Henson does come into it.
That's right.
Basically, a interesting story that ties in an old episode of
the Sesame Street.
Sesame Street.
That's right.
In Kermit the Frog, with
a little girl
and variation.
The
importance of being flexible and understanding that things don't always go the way you want or expect them to go, but there's a lot to be learned from it.
That's right. That's right. No, it's a good lesson. Jim Benson always has interesting stuff. So check that out again. Jim Benson, not Jim Henson, talking about Kermit and Sesame Street and expected results.
That's right.
Good stuff. Okay, well, that's our show for this week.
Okay, Mike, wrap it up.
Thank you, Kermit. Thank you, Dirk, somewhere out there. Thank you all for joining us on this Friday's episode of Quality Digest Live. We'll be back at you next week with another great week of Quality Digest Daily, so check it out, and we'll see you then. Have a good weekend.
Have a great weekend.
Bye.
Thank you.